Hello everyone, I welcome you all to this class. This is mathematics class, and in this class we'll be considering the second example on this topic we introduced in our previous class. We are looking at this topic, the domain of a function. So I'll be showing you how to find the domain of a function, of a given function, with the aid of this example. We define in our previous class we defined the domain of a particular of we define the domain of a real valued function of real variable. So we say that if f is a real valued function of real variable, then the domain of f is set of all real numbers such that f of x is a real number. So which means that the domain of f is the set of all x elements of real numbers such that if I put that x in the function f, you are going to get what? A real number. With that, we'll look at this very example. They ask us to find the understood domain of this function x minus 1 divided by the greatest integer function of what? X. This symbol is the greatest integer function. This is how we denote it, with this brackets that looks like a square bracket. So this is a greatest integer function. We have x minus 1 over greatest integer function of what? X. We want to know the understood domain of it. In our previous class, I told you that if you have a rational function, that's a function expressed in fraction form, you have the numerator, you have the denominator. We normally demand that what? The denominator should not be 0. Because from the definition of domain, we say that what? It is the set of all real numbers such that if you put them in the function, you are going to get a real number. But if the denominator becomes 0, then you are going to have something over 0, which will give you what? Infinity. And infinity is not a real number. So such values of x, they will not be part of the domain. So we are going to exclude them. So this is normally the target. This is normally what we use if you are finding the domain of a rational function, a function in fraction form. You try to remove those points that will make the denominator to be what? 0. So look at the solution to this. Solution. We have this function x minus 1 over greatest integer of x, but you need to know when. So as I said, we try to remove those points that will make the denominator to be 0. So what we have here is the greatest integer function of x. When will the greatest integer function be 0? If you have, let me just sketch a little graph like this. This is y, this is what? X axis. Now this is 0. Let me say here is 1, here is 2, and so on. You can only get the greatest integer of a real number to be 0 if that real number is 0 or is positive 0 point something. Positive 0 point something. And you know, if you have 0 point something, positive 0 point something, they are between, all those numbers are between 0 and 1. Right? So it means that the value of x that will give us that 0 is what? 0 and what? All numbers between 0 and 1. 0 point something and the rest. So we are going to have that the domain of this function x minus 1 over greatest integer of x, function of x. Like what I have said earlier, it will be the set of all x elements of real numbers such that x should not be an element of 0. X should not be 0 or a number between 0 and 1. It should not be 0 or a number between 0 and 1. So you can see how I wrote it. I used square brackets for 0 and I used open brackets for what? 1. Because 1 is not inclusive. We are considering those ones that will make the denominator to be 0. That's the one we are removing. So if you remove this 0 and all numbers between 0 and 1, you will now have other numbers will give you what? Will give you real numbers if you put it in this function. They will not give you infinity. So they will be the domain. So with this, we are going to get that. So if you have your real line like this, you have 0 somewhere, 1 is somewhere here, right? And this is negative infinity, this is what? Positive infinity. We are removing this one. We are removing this one, right? So what is now remaining is what? Here will be what? From negative infinity, use open bracket, comma, then here will be what? 0. You use open bracket, because here the one you had 0 is part of the one we are removing. So use open bracket, then union. We have removed this one. Coming this side, you now have what? 1 is part of the domain. You use close bracket for 1, comma, then positive infinity, use open bracket. So this gives you the domain of this function. Thank you so much for being part of this class. I'm expecting you in our upcoming class. Have a wonderful day. Bye.